In this section, we'll be looking at the main methods of sample preparation, which are used to prepare samples for infrared spectroscopy. Now, there are four main methods of sample preparation that you need to know about. The first is a KBR disc, the second is a New-Joule mull, the third is the thin film method, and the fourth is ATR, or attenuated total reflection. So what I'm going to do now is show you a video of how to prepare these samples, and then we'll discuss this in a little more detail. So first of all, we'll look at the KBR disc method.
Okay, so in this section of the lecture, I'm going to show you how to take a IR spectrum by making a KBR disc. And we're going to do this in several stages. We're going to make the KBR disc, we're going to prepare the powder to make the KBR disc first. We're then going to take it over and use a KBR press, and then we're going to go and take the spectrum itself. So what I've got here is all the equipment you'll need in order to do that. So what we've got here is our sample of our drug, which we're going to be taking the IR spectrum of. That's here. We have a sample of solid KBR, which is this white powder here. And then we have a pestle and mortar, and we have, at this point, our sample holder. And so what we need to do first is take a small spatula full of our sample to be analysed. We put that here. And then we take a much larger volume, so about 5 equivalents of our KBR, potassium bromide. So I'm just going to do that by eye. 1, 2, 3, 4, 5. And then once we've got that mixture in our pestle and mortar, I'm going to grind it all up using the small pestle and mortar. We're going to make it into a very fine powder, so it's all mixed homogeneously, and the large lumps as it comes, as you buy it, have completely disappeared. And after we've done this, which takes a minute or so, we'll load it into our press in order to produce our KBR pellet with our sample inside it. Okay, so prior to actually putting all the equipment together, I just thought I'd introduce the equipment that we're going to be using. So here we have a press. You can see here that I can rotate this to make large adjustments, and I pump on this handle in order to introduce the pressure, because that's what we're going to be doing. And here we have our die that we'll put together, and we'll put our sample in here, and this will be put into the machine to produce our KBR pellet. So this comes in several parts, which we'll put together in a second. And then we have our finely ground powder here that we're going to put into the die. So now I'm going to show you how to produce the KBR disc, and this is done in a die like this. And all dies will be slightly different, but they all work in the same way. And on this occasion, what we have is a metal washer that fits snugly into the die. Let's put that in there. I'll press it down with this. And then I load my sample on top of that spacer. And then give it a few taps to make sure it's homogeneously dispersed around. Put the second spacer on top, press it down with this piece of metal here. And now this is ready to be loaded into our press. So we put our die into our press and manually wind it down until it just touches. You can see here the pressure gauge. And then I wind it down. This is in tons, and our die rating is for 10 tons. So keep pumping until we get to 10, and then we just leave it for a minute or so to settle. There we go. And we'll leave it there for a minute. The sample's been under about 10 tons of pressure for a minute or so now we just release the pressure, unscrew the die, which I should be able to do. We can take our sample out and we can release it and hopefully expose a nice disc of our sample. So once you've finished and you've waited your minute for the pressure to do its work, then you should have a beautiful homogeneous film like this, which is practically optically transparent. you can see that I can pick this up and manipulate it with tweezers. So once we've got our nice sample, we can then put it in a sample holder which is the right size for the dye that we used. And this is just going to hold it in the beam of the spectrometer when we place it in there, and it's just got a little cap which secures it in place. So now you can see you have your KBR disc in your sample holder and it's ready to load into the instrument. So we take our sample in its sample holder, we put it in the slot for it. The beam is coming from this side across here, so we're measuring on over this side of the instrument. We put down our light-proof lid and we hit the scan button, and it will then take 4 or 8 scans, depending on however many we choose, over about 30 seconds, and that will give us our spectrum.
Now in the video you saw the preparation of a solid sample by the KBR disc method. So in this method you take your sample, so around 10 to 20 milligrams of powder, and you grind this with potassium bromide. Now this grinding process disperses the sample into very small fragments and reduces the amount that the sample scatters the incoming infrared light. So it means that more light gets to your sample, and this increases both the resolution and the sensitivity of the technique. Now after this you transfer the sample into a die and you compress this using a 10-ton press. Now when the pressure is applied, the KBR converts from a solid to a liquid, and when you release the pressure it sets to give you a transparent solid disc. Now this disc contains the dispersion of the sample to be analysed, and it's important to note that the KBR is not seen in the infrared spectrum, so the KBR is essentially invisible to the infrared spectrophotometer. So all you see in your spectrum is the spectrum from your sample. So then you place the KBR disc into the spectrophotometer and you can easily acquire your spectrum. So next we're going to look at the New-Joule-Mole method.
So now I'm going to show you how to prepare a New-Joule-Mole for IR analysis. And again, we need our sample, we need a sample holder, and we need a pestle and mortar. But this time, instead of making a KBR disc, we're going to use pre-formed KBR discs that you can buy. And I'll just show you what these are like. They come in little plastic bags. You can see they're optically transparent, and they're the same compound, potassium bromide, that we used in the press previously. But in this case, they're much thicker. You can see this is about 0.5 centimetre wide and about 3 centimetres across. And we're going to prepare the mole, which is just by crushing our sample with this compound called New-Joule, and then we're going to paste it on these slides. So just like previously, we're going to take a small amount of our sample, about 5 milligrams, which is the tip of a micro spatula, and we're going to put it into our crucible to be ground, because we want it as small, the particle size to be as small as possible, so that we get better resolution. So because we've got less of it, just a few seconds of crushing, and we have a nice smooth sample, which you can see there. And then I'm going to take a drop of this liquid, which is an oily substance, which is essentially an aliphatic oil, and we're going to put a few drops onto our sample to make a paste, and we're going to give it a good stir. And so our crushed sample will be suspended throughout this oil. So I've been stirring our mold together to make a nicely dispersed mixture of our sample in this oil, and I'm going to take the tip of a spatula and I'm going to spread it on the top of one of our KBR discs. And then I'm going to use the second one to sandwich this, and you should then push them together and rotate them so that we have a nice thin film of our sample suspended in the New-Joule. And then we can put this into our sample holder in preparation for taking the IR spectrum of it. So just like previously when we were using our homemade KBR discs, we take our sample holder with the mole swashed between the two discs and we put it into the instrument, and then we just use it as normal and take our spectrum.
So that was the New-Joule-Mole method. Now, as you saw in the video, this is used again with solid samples. So you take around 10 to 20 milligram of your sample and then you grind it in a pestle and mortar. You then add a drop of liquid paraffin. Now, the brand that is most usually used for infrared spectroscopy is called NuJOL. So NuJOL is a brand name, but this is essentially liquid paraffin. It's an aliphatic hydrocarbon containing lots of carbon, carbon, and carbon-hydrogen single bonds. So you drop this oil into your sample and then you mix the sample with the oil. And then you drop the mixture of oil and sample onto either potassium bromide or sodium chloride disc, and then you place a second one on top. And this gives you a thin film of sample. Now, the paraffin, so the NuJOL, does contribute to the infrared spectrum. So unlike the potassium bromide or sodium chloride plates that you can use to hold your suspension of sample in oil, the oil does have an infrared signature because it contains carbon-hydrogen, carbon-carbon single bonds. So when you get your spectrum out, you would eliminate these peaks from the spectrum because you know they come from the oil. Now next we're going to look at the thin film method.
The final way that I'd like to show you about how to prepare an IR sample is just by casting a thin film of it from solution. And to do that, it's perhaps the easiest way. You take a few milligrams of your sample, again it doesn't need to be carefully weighed, you put it into a suitable container and then add a low boiling point solvent that it's very soluble in, so often dichloromethane will do. You then dissolve it in that solvent and using a pipette you drop it onto your KBR disc, and in a few seconds your low boiling point solvent will have evaporated, leaving a nice homogeneous thin film of your sample on the disc. You take these discs and you run your IR exactly as previously, and that's the third and final way that you need to take an IR sample preparation to take an IR spectrum.
So in the video you saw the application of the thin film method. Now the thin film method can be done in one of two ways. You can either take a solid sample and dissolve it in a solvent that has a very low boiling point, and then drop some of this solvent onto a potassium bromide or sodium chloride disc. Now the solvent will readily evaporate, leaving a film of your sample on that plate, and you can then place this into the spectrophotometer and acquire an infrared spectrum. Alternatively, if your sample is already a liquid, you can simply place a drop of it on one potassium bromide plate and then place a second one on top to sandwich that liquid between those two plates. And so you can use this either with solubilized solid samples, or you can use this to analyze liquids directly. Now the final technique is called ATR, or attenuated total reflectance. Now this is actually the most straightforward method of infrared analysis, as almost no sample preparation is required. Now this does not use potassium bromide or sodium chloride plates. Instead, this is the surface of the spectrophotometer. So this is a metal plate, and right in the middle of the plate, that dot that is just here, so the dot in the middle of this circle, is actually a crystal, and typically a diamond is used as the crystal. So that's actually a diamond embedded in the spectrophotometer. You then take your sample, which you can see here, and place some of it on top of this crystal. If the sample is a solid, you will then use a pressure tower, which is this pointy bit above the plate, and you will screw this pressure tower down so that it compresses the solid sample into the diamond crystal. What then happens is the infrared spectrophotometer emits infrared light, and the infrared light bounces through the crystal, and some of that light is absorbed by the sample. The beam then goes back into the spectrophotometer and is passed to the detector. Now if you look on Blackboard immediately below this video, you will see a interactive task that takes you through the process of using an ATR spectrophotometer.